Welcome to the General Chemistry 2 class. This section is on chemical kinetics. This lesson is about the reaction half-life. Let's begin. In this lesson, we will explain the effect of temperature on the rate of a reaction. An energy diagram shows the energy profile for a reaction as the reactants are converted into products. In a reaction, one of the requirements for a reaction to take place is that the reaction must have enough energy to overcome the energy barrier called the activation energy. The reaction speeds up as the temperature is increased. Increasing the temperature increases the kinetic energy possessed by reactant molecules. When molecules possess more energy, they overcome the activation energy more easily. As a result, the reaction progresses more easily. As shown on the plot, on the right, a greater amount of molecules overcome inactivation energy at higher temperatures, suggesting that the rate of reaction is faster at higher temperature compared to a reaction at a lower temperature. Consider the general form of the following rate law. If a reaction with this rate law is monitored with fixed reactant concentration and at increasing temperature, the rate is observed to be increasing. Since concentration is kept constant, we see that the rate constant K also increases as temperature increases. A Swedish scientist in the name of Svante Arrhenius found out that the rate constant increases with temperature. He came up with the equation that shows this relationship, called the Arrhenius equation. Rate is equals to pre-exponential factor times e raised to the negative activation energy divided by the quantity universal gas constant times temperature in Kelvin. How temperature affects the rate of reaction will be elaborated in another lesson. As a conclusion, to summarize, temperature increases the rate of reaction as a result of increased kinetic energy possessed by the reactant molecules, which enables them to overcome the activation energy more easily. The Arrhenius equation relates the temperature to the rate constant for a reaction. And that's it for today. Thank you for watching. Welcome to the General Chemistry 2 class. This quiz is about the reaction half-life. Let's begin. Determine if the statement is true or false. Number 1. Activation energy is the energy needed to be overcome for a reaction to occur. Determine if the statement is true or false. Number 2. When molecules possess more energy, overcoming the activation energy is more difficult. Determine if the statement is true or false. Number 3. As temperature increases, reaction progresses less easily. Number 4. This is the scientist who formulated an equation that relates temperature to rate constant. Select the correct answer. Number 5. Which is the correct equation that relates temperature to rate constant? Select the correct answer. Number 6. If the rate constant is 2 inverse second at 280 Kelvin, the rate constant at 400 Kelvin is blank. Select the correct answer. Number 7. If the rate is 0.52 moles per liter second at 350 Kelvin, the rate constant at 250 Kelvin is blank. Select the correct answer. Number 8. The rate of a reaction is 0.087 moles per liter second at 400 Kelvin. What must be done to lower the rate of 0.018 moles liter per second? Select the correct answer. Number 9. The rate constant of a reaction is 0.135 moles per liter second at 318 Kelvin. If the temperature is changed to 346 Kelvin, the rate constant will be blank. Select the correct answer. And last but not the least, number 10. A certain reaction occurring at 300 Kelvin is known to have a rate constant of 0.003 liter per mole second. If the observed rate constant is 0.019 liter per mole second, the temperature is likely blank. Select the correct answer. And that would be all. Thank you.